Ladies and gentlemen, okay, guys, question number 3. It's what we will be looking at in today's lesson. So let's see. What I'm going to quickly do is to take you through that given statement and we look at the diagram, and lastly, we are going to look at the questions. Obviously, I'm pretty much sure that by now you are aware that I'm not going to be solving any questions nor answering the questions in a form of calculations. I'm just going to take you through how you answer the question. So without any waste of time, very quickly, I'm going to read through that statement. So let's see. It says in the diagram, A. Where is A? Okay, there is A, having the coordinates -2 and 3. C. Where is C? Where is O? There is C, having the coordinates 10 and 11. D. Where is D? Oh, there is a D, having the coordinates 5 and -1. Are the vertices, remember, word vertices refers to the corners. The corners of what? The corners of triangle ACD. And they continue to say CA intersects the y-axis in F. Where is F? Oh, there is F. There we are having F. And CA produced cuts the x-axis in G. CA produced. So remember, they simply say that CA extended, it cuts the x-axis in G. The straight line DE, where is DE? There is D, there is E. Okay, what about it? The straight line DE is drawn parallel to CA. Where is C? Where is A? Oh, so that line is actually parallel to DE. Okay, makes sense. Lastly, in triangle CFO, angle F, it is the one which is alpha. Wait, which triangle now? C, where it's C. There is C, there is F, and then from there you go to O, and then from there you go back to C. Okay, that is the triangle they are talking about, and this is that angle that they are referring to, which is alpha. Okay, makes sense. I think now let's try to answer the questions. So I'm just going to very quickly remove all of these. So it seems like from time to time we might need to scroll up to some of the information there. But what I notice is that that statement, it is fully represented diagrammatically there. So we might not need to refer to that statement, but just look at the diagram itself. So 3.1, calculate the gradient of the line AC. Doesn't look complicated, and it's allocated 2 marks. So let's see. Where is the line AC? There is A, and then from A to C, there is C. So obviously, you're going to use the gradient formula that we know. Remember, guys, analytical geometry, it's a game of 2 things, not that much complicated. You actually use the same formulas to questions which are asked differently. Just be careful of that. It's not like at all the times you're going to be applying new information. That is why I always encourage you to firstly watch a lesson that I did where I did introduction. On that introduction, that's where I cover everything that you need to be aware of regarding analytical geometry. So whatever that I'll be saying here, it won't sound new to you because it is covered in the introduction. But if you start with this type of lesson where I review these questions, you might get lost and not know why am I doing what I'll be doing. So just make sure that you firstly start with introduction. So easily, that's how you work out that first question, which is allocated 2 marks. So very quickly, let's look at 3.2. The diagram itself might look a bit complicated or scary, but trust me, the questions will guide you in terms of what to do. 3.2, and that question is allocated 3 marks. And they say determine the equation of line DE in the form y is equals to mx plus c. But now, where is D, where is E? D, E. There is the line. Most importantly, we do know very well that that line DE, they just said is parallel to CA. And because CA and AG are collinear, that means also this it's also parallel to DE, because CA was produced or extended and cast the x is in G, if you remember from the statement. So here you did calculate the gradient, and that same gradient, it has to be the same as the gradient of DE. This is what I'm going to do. I will assume that gradient that you calculated there to be positive 2. You will need to calculate to get the correct answer. So that means for this question, you are having y, which is equals to that same gradient, because they are parallel. Parallel lines equal or same gradients. Then you're going to say at a point. Which point are you going to use? You use a point which is associated to line DE, of which that point is D. So that means you are going to substitute the values of D. Obviously, x is negative, y it's negative 1, and then x it is 5. So that means you're going to substitute those values in order for you to calculate the C value. Once you know what the C value is, obviously it has to be a negative value, because you realize when you extend that to cut the y-axis, it's going to intersect where y is negative or below the origin. Once you're done calculating the C value, please write it in this form of the correct gradient and also the negative C value that you would have calculated. So that's how you easily work out that question. So please, honorable members, please make sure that you do not panic as soon as you see the diagram that you are dealing with. It is the questions that will guide you in terms of what you need to do. So very quickly, let's look at that next question, which is 3.3, also allocated 3 marks, which says calculate the size of alpha, which is the angle that they want you to calculate. Angle alpha. 3 marks. Can you see, it might not be easy to know what you need to know or to know what you need to do if you haven't watched an introduction. Sure, I might need to quickly drink some. Yourself, take a deep breath and try to think about that. Okay, let's see. I think that angle alpha, let's maybe try to simplify that angle. Obviously, you are having a 90-degree there, and then if you plus it with that smaller angle, it therefore in total becomes that angle alpha. So that means actually angle alpha is equals to 90 degrees plus that smaller angle. Then this is where you will realize that actually this smaller angle, it is actually that angle of inclination. Maybe let's call it angle theta for now. So that means alpha is going to be a 90 degrees plus alpha. Now it's a matter of how do we calculate angle of inclination. This is where you need that formula, which says tan of an angle of inclination is equals to the gradient. Obviously, the gradient of that line. What is the gradient of that line? You did calculate it from the previous question, gradient AC. So that means you are therefore having tan of an angle. What was that gradient? I assumed it to be 2. So now that means you are going to say that angle of inclination is equals to, on your calculator, you just punch second function of 2 and then you get your answer there. I will just assume that answer maybe to be 35 degrees. So that means this angle now, it is 35 degrees. Obviously, that one there, it is 90. So that's why I said 90 plus that angle of inclination will be the total angle being alpha. So that means now alpha is going to be 90 degrees plus that angle that I assumed to be that. And then the sum gives you a alpha. What is it? 125 based on my assumption there. Remember, it's an angle, it has to be in degrees. So if you do not know what an angle of inclination is, it might be confusing, but that's how you easily work out that question. So now I think we are at that point where we might need to look at the next question. I was trying to think of something that you might be wondering, but I'm sure someone is wondering that what about the rounding? So when you punch second function of tan 2, you can round it to 2 decimal places because you're just going to add it with 90 and that's your final answer. So you only round off the last calculation that has a decimal. So now let's see if we can work out the next question. How many marks for this question? Let me do that. No marks allocated there. So it seems like this is just a statement, 3.4. So let's see. 3.4, it says B. Where is B? Where is B? I haven't seen B. What's going on? You see, that mini pause, it shouldn't confuse you, honorable members. They're just saying B is a point in the first quadrant, such as that A, B, D, E, in that order, forms a rectangle. You know, a rectangle could be something of that shape, it could be something of that shape, or that shape. So in this case, what shape are we going to be having? So let's see. A, B, D, E. So possibly B in the first quadrant. For now, let me just assume it to be somewhere there. Why there? You will understand why. Because you need to say from A to that B that we suspect it to be there. When you connect from B to D, there. No, I think I might need to try and redo that. It has to make sense. You will understand why I need to get it correctly. Let me say from D, let me go there. No, again, it doesn't look right. Maybe let me do it this way. Let me do it that way. Almost. Okay. Maybe let's continue. And then from there to E. And then also when you join that, it has to look like a rectangle, with that being assumed to be point B, most importantly in the first quadrant. Can you see? Just make sure that you read the statement and fully understand. So let's see. Now they are saying calculate giving reasons. There, let me scroll and see what are we dealing with there. 3.4.1, calculate given reasons. There, coordinates of M, the midpoint of BE. We do not have the coordinates of B, we do not have the coordinates of E. But what we know is that we do have a rectangle. And what we know about a rectangle is that we have diagonal lines which share a common point, being the middle point. It has to be a straight line, that one. Let me try to do it. No. Now I'm erasing. Let me do that. From B straight to A. Yes. Can you see the diagonal lines? That's what you need to do. You've got a common point there. So that means if you use AD to determine the midpoint, it is the midpoint of BE. So that means for this question, you are going to use the midpoint formula to calculate the midpoint using x at A, that you plus it with x at D, and you divide those by 2. Y at A, you plus it with y at D, and then you divide those by 2. The answer that you get, that's how you would have answered this question. So now they're saying calculate, giving reasons, the length of diagonal BE. Again, they are referring to that BE. Remember, as you calculate, you need to give the reasons. So now, obviously, examiner said the length, but at this point in time, we know that when it comes to the length, at all the times we use the distance formula that you need to always know by heart, and make sure that you don't forget that squared. So you still substitute the coordinates of A and D. This is where now you need to give a reason. The distance that you get when you do that calculation, it is the distance of BE, based on the reason that you provide. And that is how, honorable members, you score yourself 3 marks for that question. In total, 14 marks for this question. So I think there, honorable members, I did make sense. So just try to work it out and see how far you can go with that one. So, guys, I think it is that time where I need to sign out and say, ladies and gentlemen, I do thank you very much for joining. My name is Desmond, and I'm out.